So let's start with question 6.38. In next class, we're going to come back and we're going to try the rest of these. Again, these come straight from your textbook. The reason I made a PDF of them is because it's so time consuming to draw every single molecule. So this way we can just kind of spend our time focusing on what you're trying to learn in this class, which is what? Trying to draw the curved arrows. So let's see here. Let's start with the first one. We're going from this compound that has two aldehyde functional groups, and then we're ending up with a proton over here. So this must be some kind of proton transfer, right? And we're taking the lone pair, and it's going to take a proton from the hydronium, which is an acid. So an acid is an electron acceptor, and it's going to accept, oops, I didn't mean to do that, this pair of electrons like that. So there's our proton transfer in our first step. Let's move on to the next step. So the next step, now I'm just looking at this step right here. Could anybody tell me what's going on in this step? Would this be a proton transfer, a nucleophilic attack, et cetera, et cetera? Could anybody tell me what's going on in this one? It can't be a loss of leaving group because nothing's being lost, right? We're forming a new bond. You can see that we're forming a new bond right here, right? You have the water, which can act as a nucleophile. And then since you have this double bond over here, right, you could also write it like this. You could write this like this, okay? Just put R over here where you have the positive charge here. So this carbon is really delta plus. So that's a really powerful electrophile. So what's happening here is a nucleophilic attack, right? The water is acting as a nucleophile and it's going to attack right here, but you can't have 5 bonds to a carbon. So it's going to break a bond to form this hydroxyl. So we're going to break this bond like that in the nucleophilic attack. All right, good. Well, let's move on to the next step. So we just kind of follow it around. Oops, I didn't mean to do that. You kind of follow it going this way. So the next step would be this one here. Okay, the next one is another proton transfer. Right, we have another proton transfer here. Why? Because we're starting it with a proton here, and that proton is gone. So that means that our water molecule is going to take one of these protons, and we're going to put the lone pair over here, and our next proton transfer. Then we have something happening right here. Could anybody tell me what's happening inside this green box? Remember, I'm starting out with nothing on this carbonyl, and it's ending up with a proton, right? Because I'm going, look, I'm going in this direction. I'm going around like this. So this is my starting material. This is my product. What's the difference? Here I had no proton. Here I do have a proton. So this must be a proton transfer, right? The carbonyl is picking up the proton from an acid, which is a proton donor. Okay, so then we go to the next reaction over here. So we'll take the green arrow again. So now what was the product before? This is now our reactant. This is now the product. So what's happening here? Remember that when you have an oxygen with a positive charge and a double bond, that this carbon is a really powerful electrophile. That's really delta plus. And we have 2 hydroxyls over here, which make good nucleophiles. And we're also forming a 6-membered ring. So that means that this is going to be another nucleophilic attack, right? One of these hydroxyls is going to attack the electrophilic center. I'm going to push my electrons up like this, and then you can count the number of atoms in the ring. You would have 1, 2, 3, 4, 5, 6 atoms in the ring, right? 1, 2, 3, 4, 5, 6 atoms in the ring. There we go. And then we have one more reaction, which is the last one. Who could tell me what's happening in the last one? Who could tell me what's happening in this last reaction? This is now my reactant. Right, this is my reactant, and this is my product. There's nothing's leaving, so I'm starting it with a proton over here, and then I have no proton on the oxygen here. So this is going to be another proton transfer. Proton transfer, right? The water is going to accept the proton and put the lone pair here, right? Because your oxygen is going to end up with 1, 2, 3, 4 electrons on it like that. So that's a proton transfer. So if we look at the 30,000-foot view of what happened here, first step was a proton transfer followed by a nucleophilic attack, another proton transfer, a nucleophilic attack, and then finally a proton transfer like that.